this is one of the mini topics that's in. And you do have to know some formulas. They might be in your packet, they might not. But arithmetic series, what we're talking about is we have a common what? Difference. Yes, difference. So the formula for it is actually kind of easy. Is if you're looking for the nth term, like the 15th term, you start with the first term, and then you add little what's? Common differences, right? So I like to say this has a common difference, and the difference is equal to a of n plus 1 minus a of n. That's the common difference. And so for the next term, what you're going to do is you're going to take the first term, and you're going to do n minus 1 differences. Which is kind of interesting because when you do the geometric series, that has a common what? Ratio. And that common ratio is a of n plus 1 over a of n. See how they're kind of similar? And this nth term, 50th term, you start with a term, and then you multiply by the ratio to the n minus 1. Now, the connection between those is you'd have the n minus 1 in each. For ratio, you're multiplying by r, and for difference, you're adding that. Gabby, if you could close that door, that'd be great. Okay, so we're taking the ratio times the first. For geometric, we're taking the difference plus the first times n minus 1. And then for the sum equations, I like you to remember 2 for arithmetic. The sum of n terms is n over 2 times the first plus the last. And I wrote those in reverse. Nice. The first plus the last. That works. Remember when I added the first 100 numbers, I took 1 plus 100 is 101 times 50, which is n over 2, 100 over 2. The other formula that you've probably seen in the textbooks is they replace a of n with this. So if you go a plus a, you're going to get 2a. You take n minus 1 times d plus 0 is n minus 1 times d. This formula looks way more complicated, but it's just coming from these two. You'll figure it out. And then this one has 2 formulas. The sum of a geometric is a times 1 minus r to the n over 1 minus r. And the sum to infinity, if the ratio is between 1 and negative 1, which we'll see today, this goes to 0, so you just get a over 1 minus r. Let's review exponents. It never hurts to talk about logs, ever. Never hurts. If we have 2 to the third equal to 8, what is that in log terms? Log base what? Base 2 of 8, right? Because you can't just go log base 2 of 3. It's too easy. But also, the idea is that logs are what? Exponents. You got it. So this, to me, is the secret to logs, is being able to go back and forth. Because whenever you get stuck, if you change it to exponent form or to log form, you usually get unstuck. But then we add all these properties. One property was a to the, let's go, yeah, a to the n times a to the m. What's that? A to the n plus m. So apparently, if you're multiplying, you add the exponents. So that tells me if I take the log base a of m times n, that's going to be the log base a of m plus the log base a of n. Why does that work? Because logs are exponents. So whatever happened with the exponents, multiplication becomes addition. That happens to logs. Okay, let's try another one. Let's say you have a to the m divided by a to the n. Or you could say a to the m times a to the negative n. What's going to happen to those? You're going to subtract them. It's not much of a stretch, is it? So if we have log base a of m over n, that's going to be log base a of m, log base a of n, and what do you do with those? You subtract them, yeah. Because logs are exponents. Division becomes subtraction. Another one that we're familiar with is a to the n to the m. What's that equal to? A to the what? N times m, right? Okay. So if we see log base a of m to the n, in order for this to become a multiplication, what do we do with this little n? We pull it out in front because now it's n times, the exponents are multiplied together. Logs are exponents. Okay, is that part? Now let's do a couple of just some quick ones because I think it's nice to know some quick little facts. What's the log base 10 of 1,000? 3, right? Because it's log base 10 of 10 to the third. And what can you do with that 3? Pull it out in front. What's 3 times log base 10 of 10? Or what is log base 10 of 10? 1, so that's why it's 3. So 2 facts there. One is that you can pull that exponent out so that you can get log base 10 of 1,000 is 3, but you can also remember that log base 10 of 10 is 3. How about log base m of m? What's that? 1. How about log base 10 of 1? What's that? I don't know what that is, but I can real quickly, because I'm stuck, change it to 10 to the x equal 1. And what would x have to be to make that true? 0. So that's how you know you're right. It's 0. How about log base 10 of 0? What's that? No answer. How about log base 10 of negative 1? What's that? No answer. So what happens there is there's a domain here, log base 10 of x, where x is what to 0? Careful. Greater than and not equal to, right? Okay. And then my last favorite one, 2 to the log base 2 of 5 squared. What's that? 5 squared. Yep. How about this one? How about this one? 3 to the 5 log base 3 of 7. What's that? Right, because this can come out here, so this is going to be 7 to the 5th. Good on those? Did that help to go over those a little bit? I think it does. Don't forget study time. We just did what I wanted to do, 5 minutes, some concepts. We're going to do about 10 minutes of going over problems, and then about 30 minutes I'm going to have you work. I do want to go over this one really quick. This is a BC question that ties in some HL topics. I want you to read it and see how much of it you can get. Don't look at the answers.